Hello everyone, so today we're going to check this open source project which I have recently uploaded and based on one research, and it's about ATDP protocol, so a proxy for capturing learning ready agent trajectories. So we have here a paper, Next Generation Agentic Reinforcement Learning Systems Enable Self Evolving Agents. So what this document address and what we have. So we know that agents are rapidly being deployed in production, so coding assistant from enterprise and small business or big businesses, custom support chatbot, but they remain fundamentally static in large scale enterprise level. So all those prompts, system prompts, and memory, skills, etc. Right? So any improvement require a loop of human curated data collection. So offline fine tuning, feeding some data, correcting some data, and checking, and then deployment. There is no enterprise grade comprehensive data proxy that we're gonna check because we have that, and there is no standard agent trajectory data protocol, and there is no unified agent evaluation control panel with automatic triggering that decides on the basis of trajectory data. The goal is not just observability. Goal is to preserve agent experience. So that can be used for worker replay system, evaluations, or training pipelines, right? So LangFuse is just observability. So we are not talking about LangFuse, we are talking about more on agent experience, what it has been thinking, and which in system was it, and what it have experience, which tool, which memory, what wrote in memory, and what it did. Also, this can be useful when you have multi-agent system, when you have autonomous agents that, let's say you have a task and a research task, and you pass over to one agent and it do the work, and then pass back the result to the first agent, but there was something wrong, and then it can see all the traces, all the trajectory data, and can adjust then system prompt or skills or tools, and can re-give or reassign the task. So you can use it there. So normally the point is now, right, when we have agent, chatbot in development, we make them before we give it to the customer, we test them, and mostly you would be using LangFuse observability, and you see that what agent is responding, or if you're using A2A protocol where the routes are going, and what it produced, right? And to correct it, you would go to your system prompt and then you will adjust it. Or you have evals. We have videos also on deep evals that you check what response is coming, so you know already what should be the response, and then you measure that response if it's correct or not correct, right? For instance, let's take an example. There is a system that uses LLM, and in an example, if it rain, it capture a raindrop, then it should close the doors or windows. Capturing rain, so kind of sensor there that you can think about a tool attached to that LLM, and when it predict that, and it should close all the windows. Working everything fine, but one day it suddenly closed the doors and windows, even it did not rain. Now what happened, right? So we need that trajectory data, what agent was thinking on that time, what was sensor reporting on that time, and why it took that decision. It could be any reason. Maybe the neighbor from top was giving water to plants and one droplet fall down on sensor, and it was on your balcony and it closed your door. So it's just an example, right? And you want to reproduce that, and you want to fix that. You maybe need to change system prompt, or need to add another tool, or maybe there's weather tool, it never checked the weather tool, right? And why it did not decided to check the weather? Because if you would have checked the weather, it's sunny, so it's not raining, so there is no rain. From this trajectory data, then you can correct, you can give in a feedback, you can give in a reward, and then can use it for your memory writing or prompt changing, system prompt changing, and can replay it and then see now how the system behaves, right? Or you could train the data. In our case, because we're working, let's say, building a chatbot, customer assistant, obviously we were not gonna create LoRa and some agent training. Mostly in our case, we're using inference, have a model we're using, we change the system prompts, right? We not go to the transformer layers, which we also seen in the last video. And so you want to see what the agent was thinking and how the decision was made, and then you correct it and then you replay it. You could also use it for evaluations. Also from the research paper here, that's from there, a screenshot, so that we can have a system. It can be Crew AI, AWS Bedrock, Cloudflare, any agent, right? That we need a proxy, some kind of, that we can capture all the interactions that going on, or thinking level, and that trajectory, and then later can be used in a training service. We could automate it, for example, because we have raw data and we can do many things with that. So here is the project that's been called ATDP, so inspired from that research here, that paper from here. Yeah, what does it do? Why this is useful? So observe, agent, tool, memory retrieval, MCP resource, which action was taken, what outcome, and if programmatically feedback was given. This is also a point that normally you won't do it in production system, put this proxy and then try to change your system prompt, right? You would do it in development system, but you can have this proxy in production system just to collect all the trajectories. Or maybe you have a use case where you want to automate this thing, so that we have raw data, and if something need to be adjusted, we can do that. While we are in development, we could ask your question, and if it's wrong, then you can give any feedback. So easy way would be, the thumb up, thumb down with comment, or just typing, hey, this is wrong, or calling this endpoint, giving the feedback, and so consuming these endpoints from this project. And that later on, that data you can use for evals or create a small script that can adjust, or even pass to an agent that can adjust your system prompts. It's compatible with all OpenAI compatible APIs, so Grok, OpenAI, AWS Bedrock. We will be testing Ollama. I have installed Ollama locally, and we will have a look. So all the documentation here, all the parameter, configuration parameter, all the API endpoints, right? And for Ollama, I have also added one extra document, just separate from README, so having less information, focused only on the local testing. You need Docker, UV, curl, JQ would be nice to have, so you can format the result. And yeah, so I would say less talking and more coding, or more prompting. In our case, it's more just using those commands. So far I am on this project. I have no any data so far, empty. So the first step is we need to start the Docker. So we don't need to check the test and everything. So we need to start the proxy. I have added here extra Docker file as well. So while it's starting, I will switch to, it's already up. I will switch to now a new tab. Here is the use case, right? Like non-streaming, capturing here the response, saving it somewhere so that it don't print on the terminal, and getting that request ID, response ID, or if you want a streaming response, you could also have boundary capture, record a tool call, tool result, retrieval query, MCP call, so on. So everything is here. What we gonna do, because this here an example of positive case, because here something has been asked and it's been rewarded, like great, you did nice job. I want to test it something that LLM does not know, and then we will give in a reward, minus reward. So think about something in your company, there's a word or terminology that for sure LLM does not know. We need to create first session ID, and then I will copy one command, so this command, but I have a different here message. I'm not asking to summarize this one, so I am just asking what is LNL. What is it? Nothing. It just made up text, and I'm using this model, so Ollama is locally installed. Yeah, and I just have two models for testing purposes, and there should be our output, and yeah, we don't want to print it. Output has been produced and trajectory has been created. If we check first the output, where we have saved in this temporary file, and this was the output, and this was the reasoning. So like I told you in the beginning, so it's nothing. It does not know what this LNL mean. It's asking to give more context, and that's the reasoning here, right? Now in our answer here, we will save that answer in a variable, and the response ID also from that. So our in that choices, can I scroll up? No. The first message content was the answer, right? And then what the response was from the headers, and I will just print them out. So our session ID, which we created in the beginning, is this one, and we could also consume directly here trajectory path, and pass it ID here and enter, and we should see that data, right? And we are just doing by command because it's easy to read and we can format it. So this was the response. Does not know what does this LNL mean, and now we will give it a negative reward, right? So you probably testing it somewhere in your system, and so that data can be produced and later can be consumed or in automated flow. So I have event ID, and I'm giving reward -1, and I'm saying missing private domain knowledge. It does not know. This is my label. And LNL means Lorem Norway Limited, a company. Just a text for testing. This company does not exist. I hope so, because I just made up this text. Next command, we can tell that this is in a memory write. So we gave the feedback, get the feedback ID, and that should be the feedback ID, right? And now if we check the trajectory, we should see all the data. So we can also do it with the command line. That for me easy to read by a command. Yeah, so we have outcome. So LLM still does not know, right, what LNL mean. We create a trajectory, and this we can now use for you can put in some kind of script or give it to agent and can either create a memory adjustment automatically or in evals to consume this data. So, but we have whole trajectory. So we added as an event here that memory write, but we haven't changed any knowledge correction, right? But we just create an event. So there is whole trajectory starting till end, which URL, which model has been used, and what content was, what reasoning was, and we given a reward updated, and we don't have any replay and session ID, and that the reward outcome, no any governance, no any guardrails we don't have, and we didn't publish any event. So that's pretty it. So maybe at the first time can be challenging to understand all these commands, but pretty straightforward, and all API endpoints has been documented here. Now the advantage here is that we have a trajectory story. So it created a data here, ls data. We see we have two files, and we can get this file, and there's our all data, right? So we have created here in the proxy. It's not full ARL 2.0 because we are not training any LLM, and so this part is on your side, so there is no training controller, and but you could use that, right? Because we have trajectory and we can do a lot of things with that. And also, if you have a Python project, there is also documentation about it. You can import that and use that, right? Capture the memory, right? Yeah, that's pretty all. So in the last, this open source project is based on ATDP, that document that I showed you. It's inspired from that, and we create then a proxy that capture and store all the data in a trajectory storage, and which we can use then for giving a feedback, or when we're in development or in production, capturing all the data and consuming it in training LLM or creating system prompts, a memory adjustment, or in an automation. So feel free to contribute, feel free to check, feel free to test. If you find something, create an issue or drop me a comment and we will have a look. And yeah, that's pretty it. I would say thank you very much and catch you next time. Bye bye.